going to talk about something new, something innovative, and something which is surely going to set a benchmark in the construction industry. Before we take this forward, I request each one of you, the entire extended family of APL Apollo, can we all start this evening with a round of applause, everybody? Thank you so much. So, I was talking about something new, something innovative, or I must say something which is surely going to redefine the landscape of construction in India. Well, when I say that, I really mean it. Today, we're going to talk about Nai Soch, the next-gen steel building solutions. Talking about APL Apollo, India's largest producer of structural steel tubes, has now come up with steel building solutions for the construction industry. Its high diameter tubes are now being used for construction, making the solution smoother for you and moreover faster for you. And that's why we say it, build better and build faster. No more dust clouds, no wastage of water, or I should say, how about making the building construction environment friendly too? Now, you may ask how. Well, why? We have gathered here, this is the only reason. Today, we have all the veterans from the construction industry together under one roof. So over here, I would first like to express my sincere gratitude to each one of you for taking out your precious time from your busy schedules and for being a part of this. Ladies and gentlemen, our speakers are from the field of steel tube manufacturing, construction and fabrication work, structural engineering and architectural planning. To initiate this, today we're going to have from APL Apollo, Mr. Anubhav Gupta, Chief Strategy Officer. And to take it forward, we're going to have next Mr. Pankaj Goyal, Structural Engineer, TPC Technical Projects Consultants Private Limited. From there, we're going to take this forward with Mr. Anil Bansal, Architect, Vastu Nidhi. From there, we're going to have Dr. Abhay Gupta, the Structural Engineer, Skeleton. And then to conclude, we're going to have Mr. Narendra Singh from the steel construction background, cladding. So ladies and gentlemen, without any further ado, I would like to invite on stage the Group Chief Strategy Officer from APL Apollo, who focuses on strengthening the strategic capabilities while also identifying and evaluating innovative opportunities for APL Apollo in the longer run. He also advises on corporate development, communications and marketing of the APL Apollo brand, aimed at creating a strong positioning of the company within the domestic and global markets. He has over 14 years of experience in industry research and business strategy. Please put your hands together and join me in welcoming Mr. Anubhav Gupta.
Good evening, everyone. It's a real pleasure to have you here. It's a lovely evening, and we thought to gather every one of you so that we can talk about a nice soch in the construction industry. We being the largest structural steel tube company in India, we are coming out with some building solutions which we think could revolutionize the industry in India. And with your graceful presence, with your support, we believe that we will make this happen. So this presentation is about build faster, build better, with a lot of support from some of you sitting here that we could execute some of the projects in the last 3 to 4 months. And with that confidence, with that conviction, we thought it will be good to make everyone come here and talk about it in detail. So when we are talking about revolutionizing the construction industry, it is about looking at the problems what the industry is facing today. It's about speed, it's about quality, it's about environment, and it's about cost overruns. So how do we achieve all these into the projects? We believe go for tubular construction. So the number one thing which comes here is the speed. As you can see, there are like all the parallel activities which take place simultaneously. Once the drawings are finalized, the manufacturing of all the steel sections, the cut length sizes which go to the fabrication yard. At the same time, the contractors are working on the civil foundation. They are making the foundation ready. The fabricators, after receiving the tubes, they are working on the fabrication, putting up the end plates and putting the material on site, and then the erection starts. So that's how we are able to achieve speed here, and one of the very prestigious projects from the PWD in Delhi, which got executed very recently. So right now what's happening is that the tubes in the construction space or the steel structures are not used to the optimal level. What we see is that the current consumption of tubes is not more than 15 to 20% in any of the structures. And why they are used right now is the truss, the joists, the columns, the bracing, and the facade structures. And why not more? Why not make the structure more efficient, more optimal? So right now, what the industry is facing with the tube manufacturers is the unavailability of tubes of high diameter sections and also the timely availability. The limited size range, what the manufacturers are having right now in their catalogs. They ask for large MOQs, which is not feasible for many projects. The lead time is very high, which goes up to 2 months to 3 months, of course, which discourages the engineers and architects to go for tube. And obviously, the fabricators complain about the wastage if they work on the hollow steel sections. So we'll talk about how we are addressing all these concerns and all these myths what are for tubes. We're going to vanish them. The applications of steel tube construction is across real estate projects, infrastructure projects, whether it is high-rise buildings, institutional buildings, residential buildings, warehouses, cold storages, factory sheds, food parks, oxygen plants, aviation hangars, and of course the upcoming data centers. Where steel tube wins over conventional RCC is the speed, number one. Any slab what we are able to achieve in RCC is like up to 7 to 10 days, depending on the floor plate size. In RCC, whereas we have on an average of 20 to 25 days. And this 16 days saving is quite significant for the developers or for the owners of the buildings, as they can improve their IRR, which are like internal rate of return on the investment what they are making while making the buildings. They get extra carpet area, they get their buildings, whatever the hotels, the hospitals, they can pre-advance the cash flow so they can start the building early. And what they have to do against that is they have to pay 250 rupees per square foot extra. But against that, if they get 2% additional carpet area, so that cost gets mitigated immediately. The other reason that why steel tube construction is becoming prominent is environmental friendliness. We are seeing that we all reside in Delhi during the winter season. We know that when fog comes, the government has to ban the construction activity because the conventional RCC acts just in the air. So steel, there is no dust. At the same time, the groundwater consumption is very high when there is RCC construction. In steel construction, we are able to save that as well. Other benefits, the construction time is reduced by 30 to 50%. By also paying 250 rupees per square foot extra, but the benefits from the pre-advanced cash flows, the actual returns will be much better going for steel, and steel buildings have recyclability as well, superior strength, better resistance, and we can also achieve extra tier height up to 6%. If it's like super high-rise tower, there could be addition of a floor as well. This is some study which we find out from global experts about the decarbonization. So right now, globally, 30% of CO2 emissions come from the construction industry, and globally, structural steel is being preferred because it is infinitely recyclable. It is easy to prefabricate, it has better volume to weight ratio, and the research suggests that if we replace reinforced concrete with steel structures, the emissions globally from the construction industry could be reduced by up to 60%. This is some comparison what we did between RCC and steel construction. So some of the parameters, we have excluded foundation here, foundation cost, it's the superstructure. The concrete rupees per square foot comparison we have shown. So I mean today the RCC construction would be like around 800 rupees per square foot. Against that, the steel construction is coming at 1076. So that's the cost difference what both technologies are offering. Then also what we have observed is that the tubular sections are more optimal or better than the built-up sections which are being used. Now, if we look at built-up sections, they are being used for ages. Even 100 years ago, when in New York City, the Empire State Building was built on the built-up sections, then the hollow steel sections came into the construction. But then, because of the non-availability of large sizes, the contractors again shifted to the built-up sections. And versus built-up sections, tubular buildings are also offering a lot of benefits. It's more fast even than the built-up section. The lead time of the section is low because the tubes are being manufactured on rolling mills which are running at 200 meter per hour speed. It is easy to weld because it's a single seat which comes online on machinery, whereas for built-up it's all manual welding what a fabricator has to do. Then again, the built-up sections for high-rise buildings, they need to be shuttered, they need to be encapsulated, so which may not be required in tubes. So you get additional 2% carpet area here as well, and aesthetically tubes are better. And for anyways, all of the friends sitting here are using tubes for large span projects where the span is beyond 50-60 meters. So why not use tubes for the lower spans as well, as they offer a lot of benefits. These are some of the myths what we have gathered from our industry friends about the tubes. So myth one is that the voltage connections are difficult in tubular section. It's not the case. We have done a lot of research with the people sitting here with their help, and we have been able to come up with very good solutions for these connectors. Some of the samples we are having here as well. The second myth is the raw material cost becomes high because tubes are expensive compared to the base plate which fabricators buy. But then the fabricator also includes the cost of fabrication, right? So if you look at on net basis, per kg basis, tubes will still be at least 1 to 2% lower even on per kg basis. And with the lower steel consumption on per square foot basis, the cost would come down by 10 to 15% as well. Then unavailability of bigger sizes, yes, it's a problem. But companies like APL Apollo now are expanding the distribution base, manufacturing base, and we are ensuring that the super sizes are available for projects on time. The fourth myth is that the tubes require on-site fabrication. But again, if you put the connections end plates correctly, there is not even 1 ton of steel which needs to be fabricated on site. Architecturally, aesthetically, we have seen tube buildings are better even for sheds and high rise, and the wastage of material is high because APL Apollo provides cut to length sizes. If your project requires sections of say 6.7 meter, we'll supply the tube to the fabricator of 6.7 meter height, so that there is no inventory, there is no wastage for the fabricator. There is one exciting product what we are working on is the connectors, because we get a lot of inquiries from architects and structural consultants that how to go with the connectors on tubes. So one video I like to show here, and we have the live sample also, which we'll see later. Used for our recent project with Delhi government, and 2 samples, connector samples, we are working for another project which should go live in next 2 to 3 months. Yeah, so splice connection with tubes. So this price connection, we believe it's going to revolutionize the steel building structures in India. One can achieve so much of space savings, and aesthetically the buildings can look much better. These are some of the case studies what we have done between built-up and tubular. It's for a 40,000 square foot warehouse shed of like clear height of 9 meters and span of 35 meters. So what we have achieved is 20% weight saving, and this has been vetted from IIT Roorkee at the same time. This explains that how we get the extra carpet area using built-up versus tubular. So what do we believe is that almost 2 to 3% of the carpet area could be increased using tubular sections. Now this is what we are really proud about, the ongoing hospital projects with Delhi PWD. There are like 7 hospitals at 7 different sites. The work have started for 5 of the sites already, and the projects are at various stages of completion. The structure is completed. We have a team from the structural consultants, the architectural consultants, and also the contractor who have done the project. So I thank technical project consultants, RCOP, and San India team to be here and to talk about this project in detail. So one point I like to highlight is the 15,000 ton of steel which got manufactured, delivered, fabricated, and erected at these sites within like 3 months average time. That's the average time for any of the project. And these are the sites for some of the projects. The average erection time is like 1 to 2 months. Before that, all the preparations regarding foundation and material dispatch on site. These are some of the other projects which are in pipeline. Very exciting 32-story hotel tower, which is under design stage in Bangalore. Apart from that, other various buildings across India. This is the oxygen plant which got completed using tubes last year. The execution time for this project was 15 days. From the day of manufacturing of tubes to the dispatch of material and fabrication and erection. It's a small shed, 15,000 square foot, but 15 days was the total project lead time. These are some of the projects where the tubes are used in industrial sheds. It's a 80,000 square foot shed with 15 ton crane capacity. The best part here is that the cranes are running on tubular sections. This is one of the myths that tubes can't be used for crane, but it's a live project 40 kilometers from here. I would request you to go and have a look. It's a 350,000 square foot industrial building shed in Raipur with multiple cranes, 30 tons and 40 tons, and height of 12 meters and clear span of 20 meters. So I guess a very important point what we have been touching is the speed, which is 8 days per slab. So these are the activities what we have seen in the hospital projects. Day 1, site mobilization. Next day as well. Day 3, erection of columns. Then main beam erection on 2nd and 3rd floor. Day 5, main beam erection at 1st floor, and then secondary beams, and then fixing of deck sheet, and then the concreting. So that's how it goes. Our sections anyways are like 12 meters in height, so it covers 3 floors. And if everything is done well, the speed could be 7 days as well. Now this again becomes very important, that what are the factors to achieve the speed. The contractor will require approved architectural drawings, structural drawings, shop drawings, disbursement of funds to the contractor, which becomes very important, and the clearance from any government body which is required, and clear and ready site to start the work. These are some of the tubular buildings globally, and happy to share some are in India as well. L&T has done two projects in Bombay. Apart from that, we have building in Australia, New York City, Pune. It's an ongoing project. In China, we have like as much as 70-story towers. Then hospital building. L&T has done one more project, DRDO in Bangalore. There's similar building in Jammu. Mr. Dr. Anubhav Gupta is present here. I'm sure he will talk about it. And the city wall in London. So tubes are anyways being used globally for super construction, but in India, the buildings you won't find many buildings. What is the reason? I mean, India, it's not it's a very highly cost-sensitive market. So our developers ready to spend that extra 250 rupees per square foot upfront. But then the benefits what we are getting against that. So we are sure that the acceptance will increase. In India, project deadline hardly matters. So to achieve 8 days, 9 days of speed for one slab, is if anyone really take that pain upfront. RCC construction is unskilled labor work oriented. We have a lot of subcontractors who are willing to do work with unskilled labor. In steel, we need skilled workmanship. Cement availability is very high in India, and India is anyway the second largest producer globally. The lack of availability of large steel section, this has been the reason, but we are trying to address this. We are already doing 300, 500 square diameter tubes, and very soon we are starting 1000 mm square as well. A lack of availability of higher grade steel. For all these buildings, what we are seeing is the structural engineers design their buildings using 350, 450 grade. So only Tata Steel, JSW Steel have this material available. So we have good supply tie-ups with both of them. So we don't face a challenge. And of course, contractors also are in their learning curves to adopt this technology and have the quality engineering and workmanship. Again, the point is that tubes are being used in India as well, not in high-rise, but for airports, for skywalks, for cricket stadiums, for the Tartu corridor in refineries. So why not in high-rise as well? After this, just few pointers on our group. With a lot of confidence, a lot of conviction, we are suggesting you that if you look for tubular construction, we are here to back you with the sizes which are required, on-time delivery, the technical expertise on the connections and structural drawings as well. We have in-house team of 10 designers, and we are also affiliated with top consultants in India who help us with designs. And why we are doing this? We believe that we are India's most innovative building material company. A lot of products we have introduced in India or globally for the first time. We were the first company to start to manufacture square and rectangular tubes way back in early 2000. Then we were the first company to introduce pre-galvanized coated tubes. That was like 8 years ago. We are the first company to introduce direct forming technology from Italy to manufacture steel tubes. First company to introduce 300 square diameter tubes 4 years ago. First company to introduce 500 square, 1000 square diameter tubes. And first company in India to have a full tubular building, which the hospital projects we just saw. And in flats also now we are making inroads for color purlin. We have introduced a 3 mm color coated, pre-color coated sheet, which can be used for various fabrication jobs. So this is what matters to us: innovation, and with with this conviction, we believe that together we can revolutionize the construction space. Needless to say, the benefits, the support which we are going to give to all the contractors and fabricators, tailor-made sizes, smallest of the MOQ, even of 2 tons of tube, we are happy to supply. Lowest lead time possible. We have 11 plants across India, 800 distributors. Some of the distributors are present here. Thanks to our distributors and ensuring that the project doesn't get delayed because of that. Cut to length sizes so that fabricator doesn't need to have inventory and his fabrication work gets reduced. Yeah, so this is what we believe we can try to bring some change in the construction industry. Thank you so much.
The next gentleman we have has Masters in Civil Engineering from State University of New York, Buffalo. And he's the Managing Director and Principal Designer of TPC Technical Projects Consultants. He has over 26 years of rich experience in structural analysis and design of various types of projects of any magnitude across India and internationally. He has led a wide range of landmark projects in steel and RCC structures, which include large-scale group housing, hospitals, shopping malls, IT buildings, star hotel, airports, sports stadiums, and data centers. Some of the prestigious and landmark projects designed by him are the Grand Venice Mall, Greater Noida, Ambience Mall, Gurgaon, IIT Hyderabad, Medanta, Max and Fortis Hospitals, AIMS Hospital projects. Talking about his company, TPC, Technical Project Consultants possess more than 4 decades reputation for designing numerous landmark projects with state-of-art designs, uncompromising quality and high ethical standards. TPCL's knowledge of structural engineering, quantity, surveying and cost control and project management is imperative. In addition, TPC carries expertise of building health study, retrofitting and seismic analysis. Please join me in welcoming Mr. Pankish Goel. Can you all please come hands together?
Good evening everybody, and thanks for such a nice introduction. So I remember the first day when we were to start the design of the COVID hospital. This was the time when COVID was at its peak. I was at my home and I got a call from Mr. Gupta from our board. And he said, well, we need to build these hospitals very fast. We need to be up and running these hospitals in 3 to 4 months. I said, okay, so we started to thinking about it. I said, RCC mein to nahi hoga. So that was the first very clear indication. So I said, let's try to go with steel. So we started to look at everything, and naturally, we looked at the normal conventional steel building with joists and everything. But then, the thought came up that can we do with tubes? This was also one of our initial, studies on doing buildings with tubes. But we looked at it positively, and we studied it, and we thought, yes, it's a good option. And that's how the story began. That can we do the building with tubes? So first, the foremost reason why we looked at it was the columns, because without the using the concrete outside jacketed column issue, it becomes quite a lengthy procedure in construction. That's how the first thought came up. Well, let's use concrete filled tubes or just the columns, and then join them with joists. Then we got Apollo. They said, why are you only using it in columns? Why not use it in beams? So we said, okay. So that was the next study that happened, and finally the proposal came up, and we started to design with the tubes. So the COVID pandemic had impacted hospitals all around the world. Many hospitals have scaled back or postponed non-emergency care. And certainly India was very much impacted. The PWD Delhi wanted to build these hospitals very fast. And we all know what happened. We had a deficiency of the beds. So these hospitals came up, and we were involved in design of 6 of them. As Anubhav said, there are 7 of them. We are designing 6 of them. we designed the one in Shalimar Bagh, GTB Nagar, Sarita Vihar, Kirari, Sultanpuri, Raghuveer Nagar. So they have been, the process started, the tendering process started, I think, in somewhere around July, ended in October to November. So that was the first challenge which I always feel that, we are trying to build fast, but the initial process in our countries takes quite a bit of time. You're trying to build in 3 months, but the initial time in itself extends beyond the time that we are trying to build. As a structural engineer, it frustrates me. Why can't we have shorter spans where we are able to at least get these projects up and running? So ARCOG were the architects, we were the structural engineers, and PWD was the client. So one of the reasons that we use the steel tubes is that they perform better in twisting and their stiffness is much better in the minor direction, bending capacity is better. It performs better in buckling due to its less slenderness ratio, which certainly is a problem with I sections. It has got, steel per se has a better earthquake performance, very much important for hospitals. No shuttering required in composite columns. I think this is a very important point, which was certainly is a game changer for use of concrete tubes. Less construction time requirement, I think Anubhav has already talked about it. Total offsite leading to lesser construction time. I think these last two points are most critical for these hospitals. The sites are very tight, especially if you go to these sites, there is very little space available. So as we started the process, of designing, we also faced certain difficulties. And one of the most difficult thing that we had was the connections. So connections, I had my team, they worked day and night. Mr. Rajan, I hope he's there. They found out very innovative solutions to making these connections, and we then discussed with Apollo also that they can standardize these connections for the future, which I think they are in the process of doing. The second difficulty that we faced was that at that time, Apollo was only making maximum up to 300 mm, and we needed bigger section. So ultimately we were left with no other choice but to go for concrete filled tubes. So up to there are 4 stories, and up to 2 stories, all of them had to be concrete filled tubes, which also leads to a bit of difficulty during the construction site. But if the higher sections are not available, that has to be done. The composite secondary beam design was not available in steel tubes in standard softwares. So the composite action we had to develop our own software for it. We did that, and now we have been able to make it as a composite section. I think now they are also trying to get it incorporated in ETABS. Is it already done? Is it already a part of ETABS now? I think they have been able to get it incorporated. The deflection in secondary beams were high. So for designing the beams, we had to consider live load we had already considered live load of 1.5 kN per meter square as unshored construction. But the deflection was increased due to the excessive construction live load in some local areas, which always happens in our sites. So we have to propose prop support below the metal deck sheet. This has been done by PWD, and now all issues are sorted. So this was the basic spans that we had. The spans were quite standardized, which I think is very, very important for a modular construction. Most of the spans were 7.5 meters by 6 meters. The buildings were quite repetitive, which really led to faster construction. The GTB Nagar had a height of 22.2 meters and a grid spacing of 7.5 by 7.5. Sarita Vihar is 6 into 7.5. Kirari is 7.5 by 6 again. Sultanpuri is 6 by 7. Raghuveer Nagar is 7.5 by 7. So these are some of the connection details which I said were developed along the way. So this is the connection column splice, the main beam splice connection. This is the principal and secondary beam junction details. Beam and column junction details at the column. Primary to primary beam connection details. So I would say that the second most important thing that I feel when we are designing any steel building is that we should not just look at it as a steel building. It has to be looked in entirety. If we go with steel building and end up using block masonry, I think we have defeated the purpose. So it is a concept in itself. It is not just using tubes or using I sections. It is about doing faster construction in all end-to-end solutions. So I think I would really, congratulate the architects here. They looked at it in a very holistic fashion. They have gone for facades which are prefabricated. I'll show you some pictures also. External wall panels of 100 mm thick have been used. For finishing, PVC floors have been used so that the whole process gets very speeded up. And a combination of these materials have made this fast-track construction possible. And now looking at the success of these hospitals, the good thing is that PWD has decided to add a few more hospitals with the same technology. So I think that's a feat for the technology for sure. So these are some of the desired elevations as per the architect. And these are the side pictures. So you can see it's a kind of a plug and play, kind of putting the facade immediately as soon as the structure is getting completed. No wet work is there. Everything is about prefabricated panels, glass, and that's why we have been able to achieve very fast construction. I think the construction started in December, end of December, start of January, and most of the projects are in the finishing stage. But I would like to add, they could have been finished quicker, but we were working with a government department that has its bureaucratic process, and that's why at some stages it got slowed down. And the second thing I would also like to highlight, and I think it is for all of us to discuss, is this process of fabrication drawings. That in any steel building that is taking so much time that it actually ends up slowing down the construction. I would say it was not the tube manufacturer which slowed it, it was not the contractors who slowed it. It was just the process of having one more vendor making all the fabrication drawings, then it coming to us, we finding some errors in it, again going back, the whole thing. So that I think is one of the challenges in every steel building, whether made with tubes or anything, which we need to find a solution to. So as you can see, December we started and we are in June now, and this is the side pictures. So all the walling, everything is done at site, and we hope to be inaugurating this. Shalimar Bagh is a bit behind because it was a difficult site. So these are some of the initial pictures. Thank you.
This journey started a few months ago. We have seen a lot of photographs in my presentation and Pankaj's presentation. We have made a small video of this process. It's a 2-minute video we like to run to everyone, and it will give you even more clarity that how the design was made so that the minimum sizes of sections were used, and it was easily replicable for all the 7 hospitals. Can I have the video, please?
We've been building since the dawn of humanity. For thousands of years, we've evolved to build bigger. Now comes the next revolution in construction technology. APL Apollo Steel Building Solutions for better and faster construction. Recently used to build a hospital structure in just 150 days. PWD planned 5 hospitals last year. Structural work at all the sites is almost done. The 1900 plus bedded GTB hospital was the largest built up area of more than 6 lakh square feet. Conventional construction technology would have been too time consuming. The pre-engineered steel tubes were selected to complete this challenging project in less time. 80 to 90% of the structure was built on 4 section sizes. Drywall and deck slabs were erected and cast on tubular steel structures. All steel fabrication work took place at fabricator workshops with zero on-site welding. Only structure assembly with high-strength bolts. This was made possible only with APL Apollo Steel Building Solutions. Thanks to tubular construction that offered the perfect balance of speed, quality, cost, and environmental friendliness, APL Apollo Steel Building Solutions give you lower project times, easier execution, and structure optimization. APL Apollo Steel Building Solutions, a true revolution for future construction.
Biggest one, and there the work got executed even faster. So only thanks to all the teams involved, including the contractors and India. Mudit Ji is here. Hi Mudit Ji. So, so next guest, Dr. Anubhav Gupta and Priyanka. Can we have some words about Dr. Anubhav Gupta, please?
Before I call Dr. Gupta here, I love the way Mr. Goel mentioned RCC se to nahi hoga. But hoga. Kaise hoga? That's the steel building solution for you. I'm sure that this is going to bring a revolution in the construction industry. With this, ladies and gentlemen, let us all take this forward. And next speaker we have here with us is Dr. Anubhav Gupta, a dynamic, multidimensional civil and structural engineer with vast experience in the areas of RCC and steel designing, construction management, teaching and research, and team building, imparting leadership to a group people in pursuit of achieving individual and organizational goals. Currently having experience of design, coordination, review, mentoring and execution, etc. for more than 500 projects of RCC, steel and building, industry and infrastructure sector. Talking about his company, Skeleton Consultants Private Limited, a trusted name in the field of industrial, commercial, institutional, residential and special monumental projects. Skeleton Consultants Private Limited is an organization founded on firm soil of morale, ethics and integrity, seeds of which were led by R.K. Gupta and Associates in 1989. The trio of E.R. Arun Sudhani, Dr. Anubhav Gupta and E.R. Jayesh Jain possess more than 100 years of cumulative experience in the field of industrial, civil and structural engineering consultancy. Ladies and gentlemen, please put your hands together and join me in welcoming Dr. Anubhav Gupta.
For generous reading of all whatever I have given to her, so she is word by word narrated. Thank you very much. Friends, good evening. It's a wonderful time to speak to you all, and Anubhav has already spoken about the company, about the product, and Pankaj ji has very well shown you the live example of a project which really needs speed, quality, consistency, safety, economy, everything. So it's all there. As far as Skeleton is concerned, and as far as myself is concerned, having spent 23 years in teaching, I'm always inclined towards doing something new in the field of structural engineering or whatever I do. Skeleton, we use steel, and I'm a pro steel person. Means I love using, I love making buildings or structures with the steel, for the very simple reason that steel cannot be, the properties, the characteristics of the steel sections or the metal plates or whatever, we can't alter. Means as a human being, as a labor, the people who are working, they can't alter the characteristics of that. So whatever standard IS product you get from the factory, you have to use that. Means you are sure to use a consistent product. That's the best thing about the steel. In concrete, we all know, we love concrete, that's not, I'm not against the cement lobby. But we need to be very, very careful about that product. We have to handle it carefully. 10 people making 10 concrete at the same time with all the ingredients same, will have 10 different strengths and characteristics. But in steel, you can't do that. You have to have, the only thing where you can play in the steel is connection, which Pankaj has very rightly expressed, and Anubhav has shown a new type of, means prefabricated connection also they are coming up. So some good things really coming up in the field. And I'm sure that with all these advancements, we'll be using more and more. I'll just show you some good things about steel tubes or steel per se as a construction material. And since Apollo people have called us, so it's my moral duty to speak good about the use of steel tubes and using Apollo tubes. It's perfectly honest confession. And certainly it is a good product. That's why we are here and boldly speaking about this product. I'm using also. So friends, next slide please. These are some of the sections we all know, and we all use all these forms of the steel. We have Bureau of Indian Standard people also in the audience. I am very happy that they are also participating. And the sections on the other side, cold form section, we have been ignoring them since long, neglecting. We have not been able to use them properly. And these tubes, some of them, they qualify for that particular kind of treatment also. So maybe a revision in the draft IS 801 and 806 would lead to good use of those things also. In the residential buildings, small residential building, we just can't use all those heavy sections. No? It doesn't make the economics. So those will be there. Otherwise, these we have been using from the sloping flanges to the parallel flanges, the development. And these are the new good things. What are the good? Next slide please. Okay. Efficient, no doubt. Superior resistance, as which is already explained. Aesthetically pleasing. Yeah, they look good. I'll show you one photograph. Higher strength to weight ratio. Less surface area to equivalent conventional sections results in saving in paint and finish cost. This is one of the important things. The area, surface area per square meter of a closed section is much less as compared to an open section. And that has the advantage in two things. One is painting, second is fire resistance of the things. So this is very good about the closed sections. That structure, it's not a structural building, but it's a structure. And tubes are very efficiently used in those kind of things also. Next. Some of the pictures here I borrowed from your projects only, Pankaj. Duke acknowledgements to you. So these are some of the areas where you can use, means everywhere almost, where steel can be thought of, you can use a closed section with little pre-engineering, a better pre-engineering, pre-planning and good production, all that. And certainly the fabrication drawings, it's a main point, but with good people around us, I'm sure some of the audience people must be good knowledgeable people on the Tekla software and those kind of things. So they are our strength for all these things. Next. Some of these structures globally where tubes have been used, we know some of them, but some of these things we can't imagine, but they are in tubes. Next. Our projects. This is a project in Delhi itself made out of the tubes only. This is recently won an award at national level by Association of Consulting Civil Engineers. It's a domical auditorium created inside Rakabganj Sahib Gurdwara, inside an existing building. So the roof is also made out of the hollow tubes, dome complete. There was an RCC slab, 75 feet diameter we cut. And Gurdwara slab was not easy to cut, 9 inches thick. So we cut the entire slab through cutters, 1 meter by 1 meter pieces, taken them out. And then, because there were 4 RCC columns to be removed, and then only we could have accommodated this auditorium. So we removed those 4 columns, removed the entire slab, and then covered again by steel domical roof, and then created this auditorium inside. It is International Center for Sikh Studies, 200-seater planetarium sitting auditorium, overhead projection is there. So this has been awarded by as one of the innovative use of the steel tubes, hollow sections in steel. Next. I'm proudly saying this is India's one of the largest residential development and maybe the first one in India. Ground plus 13 in Jammu, seismic zone 5, on steel. It's completely prefabricated everything. There is no concrete, no brick walls above the ground. Out of 4 towers, 1 tower has been completed. People are occupying. Other 3 are in progress. They were halted because of some issues. Now restarting. And the manufacturer, means the fabricator of one of these is just sitting here with us. Med Techno Facade, they are here only. Next. Schools we have done in around school buildings. So similar to hospitals, school people also need a faster construction. So we did schools also with the hollow sections. Next. This is an infrastructure project. Canal tops solar power project over Tista Fall Canal near the Jalpaiguri in West Bengal. And this is a 55-meter clear span truss which was all in hollow tubes. The fabrication erection was only allowed from one side. So and there were no props or support you could have taken from the canal bottom. That was the restriction. So the entire 55-meter fabricated on one side, and it is in a 4-kilometer long stretch, complete on. So that was also done in the hollow sections, and it beautifully came up. Next. This is a project which is in progress, and which is something very different we are working, and we got one good experience or learning from this. India's tallest bungee jumping tower we are doing. At Rishikesh currently we have 83-meter bungee jumping in India. There is again at Rishikesh. This is coming up with 89-meter bungee jump. On the top of a hillock we are creating this tower. Next slide please. It will be this. For any open frame section, undoubtedly circular hollow sections are better than the square or rectangular. We did this exercise with both. First we designed the square and rectangular, and then we used the circular hollow sections, and the weight reduction was 2/3 right from there. The entire. This has been designed, and 75-meter tower height, 25-meter is the cantilever boom from where the person will take the bungee jump. Again, the fabricator of this is also in the hall. Rohit, hai aap yahan pe? Is there? So they are going to make this, and the tube is being supplied by Apollo. Amit hai? Mohit hai na? Yeah. So they are the partner. कोई जल्दी दे दो उसको, वो बहुत परेशान है आपसे कि आप डिलीवर नहीं कर रहे हो. I just made good use of this platform for him also, so that we can complete the project in time. So friends, there are ample opportunities. The only thing is for all my, earlier I was told that there will not be many structural engineers. There will be users, contractors, and architects. So I took the liberty to speak something, and but then with all due regards to very stalwart, Junaid sahab baithe hain, Lal sahab baithe hain, all good knowledgeable people on the steel structures. I'm sure that you will motivate the young people who are working with you all to learn steel design. Unfortunately, steel design in our country, when I was a teaching faculty, the obvious choice for any teaching faculty also was RCC. Even on the structural detailing side, when I interviewed 10 draftsmen, I hardly get one who knows steel detailing. So that particular thing has to be developed. The capacity building in terms of आप सिर्फ manufacture ना करें, थोड़े बंदे भी generate करें, training करें अपने यहाँ पर detailing की. That's very important for you only. Thank you very much, and have a wonderful time in the steel tubes and this program.
But I believe it was a joyful session also. And this is nowhere written in my script. I'm being very true here. Okay. With this, we're going to take this forward with our next speaker. So, ladies and gentlemen, he's the one who's the managing principal and the founder of Vastu Nidhi, a multidisciplinary architecture and urban design practice based out of Noida. He founded Vastu Nidhi in 1989, and over the course of the last 33 years, Vastunidhi, under his leadership, has worked across various typologies and scales of projects across the country. With a focus on sustainability, space efficiency, and a human-centric design approach, Vastunidhi has designed prestigious projects such as IIT in Bhubaneswar and Kerala and AIMS Jodhpur. Talking about his company, Vastunidhi, this was established in 1989 and today, with almost 3 decades of experience in architecture, is one of the leading architectural design consultancies in India. Vastunidhi offers a comprehensive consultancy service from concept to completion, including master planning, urban design, architecture, interior design, project management, and engineering services. Over 120 of Vastunidhi projects completed nationally, 90 million square feet area Vastunidhi has designed, and with over 30 years of trust and confidence, Vastunidhi has more than 25,000 crore plus value of work executed till date. Please put your hands together and join me in welcoming Mr. Anil Bansal.
I think they may be partly right, partly wrong, I don't know. I think on the foray where a lot of structural engineers are there, I think I cannot add much to it. I'll be only talking of what we feel as architects, how can the technology of steel tubes can improve our building, especially on the facade front, and how they can help us do services in a better way. And as we have been traveling worldwide, we see the buildings made worldwide are looking like art pieces. And overway in India, we see the building which we plan, the lines which we put, they don't come up the way we look at it. The sharp lines, especially in RCC, they don't come out the way anticipated because of lot of issues, uneven edges. When the buildings go for faster finishing, we see a lot of gaps are there. When the casting has been done, there's a gap of 50 to 100 millimeter errors. I think with the steel tubes now, we should be able to remove these problems. It's a short presentation on how we think the steel tubes can help us. Can you go next slide, please? Now we look at the people, what we are looking at is the building should be ornamental, straight, sharp, curves, especially after Zaha Hadid has given organic architecture a new footprint. So these things are not easily possible with concrete. We have to look at alternative technologies, using steel, aluminium, etc. So I find steel tube as one of the elements which can help me do faster construction, smarter construction, and especially helping me in my facades. Next slide. Looking at some odd fronts, we have seen again, as Anubhav has told and the total team has told, speed has become a very critical aspect in the last few years. Earlier on, we were doing buildings at a very moderate speed. Now, becoming with the speed, I think alternate technologies are looked at, faster slab cycles, compatibility with the facade, services going smooth. So we are looking for alternate technologies. I'm not only talking of the steel tube, we have seen the composite technology is the right answer. We look in what is required where steel tube is required, where ice sections are required. Most of the structural engineer friends are there. I think it is not only what tube and etc. can do, what fits where, how it becomes an economy, and how can it be fit in the project. We are doing few projects with Apollo also, and so it's basically looking at what is required where, and we do a camouflage and make a composite structure. So only conventional method of RCC, and I think we have to rethink to a composite composition of the right materials and bring in the right product. Next. I think with real estate looking at and the healthcare needs a faster working with appropriate speed, and I think these slide points, I think they've been taken by the previous people also, that how faster construction and some area in the footprint can also be saved by steel tube and with composite smart technology. Next slide. I think slab cycle has been understood. This is one of the building Oculus I saw in the US, where I see how steel tubes have been used in a very decorative and a beautiful way in the complete project. The total project has been done with total steel fabrication, and it looks like a beautiful piece of art. I think a lot of people must have seen it. This is only possible once we go for composite technologies. So architects we all need, and engineers we need to all work together, looking at alternative methods where we can do faster construction and the things can come like a piece of art. Next please. Now we are looking at how can we replace lot of places, like lot of places these kind of plastics columns only for structure. So we are doing one project over in IT where we are trying to use these steel columns. You can see on the right hand side the steel columns are coming, wherein they are taking only as architectural elements just to take the top frame. The visor edges, all sharp edges we can all easily achieve with some steel tubes or by steel eye sections. So we're trying to use a lot of methods and materials combination so the buildings can come sharp and the way we want to design it. Next please. So we were looking at extruded aluminum sections with composition steel tubes and RCC. Combined can create a lot of buildings which are looking more organic, and basically we look at right combination which should be addressed. Next please. In this project we were again trying to make it sharp edges and with the steel and aluminum lures as shading devices in a lot of facades. So all the AC extractor have been camouflaged using aluminum and steel tubular sections and having sharp edges. Next please. This is one very interesting project. This is in Lithium-Melia. This is an infrastructure project. Seeing is believing this project. This is totally done in steel tubes. This is a railway station. I'll show you a few more slides also. Basically how we can use composite materials and this lighting, etc., and the glass fixing, seeing is believing. So this is basically an inspirational slide, and how we can do our infrastructure in a very fast and a very beautiful way. Next, please. This is again the same project which I photographed. You can see the sections, how the steel sections have been used with glass infills. You can see the lighting in this and the bottom row slide. How beautifully the sections have been used and then taking the light and ventilation. So this type of things cannot be created in single material. We need to understand the material, do the right engineering, and camouflage the right material at the right place to get some iconic infrastructure. Next please. Similarly for landscaping, shaded areas and pathways, parkings, similar things have been used for in steel tubes, split sections, etc., which can be done very fast, and this can be even standardized for a lot of projects. We can give them, like companies like Apollo tubes, etc., they can develop some 5-7 type of products which can be replicated in a lot of areas as standardized the way we do it in America. Next please. Now coming to a lot of larger spaces which we get, just putting by eye section, etc., doesn't help. Looking at circular tubes, straight tubes, etc., we can create a lot of beautiful atriums which add to the interior quality of the project, even the exterior also. Next please. I think that's it from my side.
Here is the men of steel. Well, yes, the CEO of Claret Projects Private Limited, who runs Claret Projects in Faridabad and has 20+ years of experience in steel fabrication and has completed more than 2,000 steel buildings till date. Talking about his company, Claret Projects is a full-service exterior and interior PV specialist engaged in the business of manufacturing pre-engineered steel buildings, roofing, claddings, walls, floors, and providing complete building solutions. With a state-of-art factory in Faridabad, equipped with best-in-class machine facility, the company has an annual capacity of 30,000 metric tons. Please put your hands together and join me in welcoming Mr. Narendra Singh.
Next one. As Anubhav says, and a lot of structural engineer already explained about tubular section. Actually, we are into pre-engineered buildings, and we are doing a huge of with tube section at Raipur complex. It's around 12,000 metric ton of tube section we manufacture at single complex. And comparison into PEP with this, it's a more than 15% reduced steel in a single site. That weight of the this complex is around 12,000 metric ton, and now in steel tube section it's around 10500 metric ton, 1500 less weight as compared to PEP because of its span. Mainly span, 3 buildings is more than 35 meters span with a train of 40 and 35 metric ton, 35 tons. And height of that building is around 42 meters in a single complex. 42 meter, 3 building. Next one, please. In compared to PEP, when we start using this hollow section, we have saved a lot of time. See, when we get a tube of exact size of plus minus only 10 mm only, cost and time approximately reduced by 3 months in a single project. As Anubhav says, paint and saving of paint, wastage is minimal. Wastage means when we get the tube size is exact as we required in the section, so we can reduce a huge saving of scrap. Next one. Structural property, as you are aware, hollow section as compared to a built up is always, because of its shape, it's better than built up section. Next one. Our running projects. These are 2 buildings with a 25 or 30 metric ton crane of around 35 meter span in Chhattisgarh, Raipur. In same complex, Duzana, sorry, this one is in Duzana. In this one building is length is approximately 600 meter, and height of that building is 42 meter. That building. Next one. This is cost saving. Comparison between PEP and hollow tube section. Average cost saving of between PEP and hollow section is more than 10% averagely. Next one. And recently, one more project we got in tube section at Kathmandu. It's a Hotel Hilton by DoubleTree. It's a 17-story building in tubular section. As compared to this open section, cost saving of this project is much more than 15%. That was done by this 4-story building. Next one. This building in Bangalore, as was already explained. Next one. Thank you very much.
Is the fire rating, because when we are talking of the public buildings or we are talking of the residential towers of high stories, the fire rating is a challenge. For that, we have to address, we all have to address, because the fire paint which is qualified for 2-hour rating, here it is very, very costly compared to the European market. So this, and if we go for other solutions of the fire rating, increase in the fire rating, then that is a time consuming. So this is the challenge with the steel industry. Other than that, everything is good for the steel industry, and good and economical also in the real term. In the present term, it may look 250 rupees costly. I don't agree with this, because if you see the life of the structure, if you see the flexibility in the structure, if you see the retrievable cost of this structure, it is cheaper. Thank you very much.
Actually, instead of the intumescent paint, we can go for the vermicomb also. That is cheaper. That is 1/3 of the rate. So nowadays it is available with 2 hours, 4 hours fire rating. And moreover, when we do concrete fill tube, whatever concrete we fill, it is also do heat sinking. So fire rating automatically it reduces. So instead of maybe 25 mm, you may need 18 mm fire vermicomb oil. So there is a replacement and there is economical solution available nowadays.
Vermicomb will take time also and cost.
No, it will not take time because it is just spray. So it is equivalent to paint only. But yes, on the columns it may look somewhat ugly. On the beams it is okay because it is to be false later on. Otherwise, it is not time consuming because whenever you are constructing the upper floors, you can do the fireproofing on the lower floors anytime. So it is not on the critical path in that. So it is doable. Thank you.
Cost difference between the customized sections and the standard sections?
No, we do charge on a per kg basis.
Consultant, what I noticed that in the hollow section, when you are doing the splicing, the size of the strength at the location of the splice will reduce because the size of the plate which you are using inside is quite less as compared to the total section. How you will obtain the full strength at that location?
The IS code which tells us that we have to provide 20% extra capacity at the splice. So I think if all the codal compliances are taken care of, I do not foresee any issues there. But yes, we can discuss further. I think it's an interesting question. I'll share my number with you, and you know what we have done in the hospitals. It is always good to discuss and see and learn.
How do we protect the inside part of it from any kind of rusting in future?
You can do always, I would say, do the fire inside the tubes, and whatever the vapors are inside, you can just burn those vapors and then close the tubes. Then rusting will be protected and it will not be done maybe in the future. All the tubes should be closed always.
I'll just add to this. When we have the fear of rusting on a steel section, the documented research says, and I think Abhishek, Abhishek na? He will agree with me, that rusting rate is like 1 mm for 675 years. So if the section is not exposed to the change of the moisture and temperature, it is like inside of the clothes, then 1 mm will go away in 675 years. So don't worry about that if there is some rusting inside. As long as it doesn't affect our friend Bansalji on aesthetics, it's okay. Exactly. Exactly. So external rusting we can always take care, and internal you can always ignore.
But the point is stating, yes, we can work with our technology where we can paint it from inside. I think that's a better solution.
Sir, it's not needed. It's not needed because it is not going to be adversely affecting the performance of structure.
Looking at the Noida water.
Your life is under inside. As long as you are protecting the inside. 100 years की life है. उसके बाद निकाल के बेच देंगे लाल साहब ने बताया. ज़्यादा पैसा मिलेंगे. तो दिक्कत ही नहीं.
Has inline galvanizing technology which paints the tube while formation online. Yeah, the mill may be running at 200 meters speed, and we have so our tube goes through a nitrogen gas chamber. which is full of zinc oxide, and while the tube is forming, the paint there is a zinc-rich paint coat on it. It's just that it is for small dia tubes, but if required in future for heavy sections, I mean that could be developed for sure.
And listening to Dr. Gupta is always fun. I wish I was at some point of time a student. I am Ajay Sahani, practicing consultant. It's a statement, first of all, for the manufacturer, Anubhav. See, we always debate in our industry that the tube, the rectangular tube versus the I section. As far as beam is concerned, since we don't get the rectangular tube is of the same cross-sectional thickness, of the same thickness all the way. I don't need the thickness in the web. I need the thickness and the material in the flange. So I section, how can an I section be more uneconomical when my basic understanding of steel is, the moment of inertia is required, I need thicker flanges and thinner webs, but you manufacture a cross section which is uniform. So I have a difference of opinion on this too.
Sir, you are correct. System, right, where tubes are better in columns and column to beam.
Column, I have no doubt.
Even
column is not at all debatable.
Right, even column to beam and maybe secondary beams could be built up sections. And we do have some case studies where we have been able to drastically reduce the tonnage if we go on hybrid model. So in hybrid model, 70% could be HSS and 20-30% could be built up sections. So in some of the projects, we are working on that as well.
Can you make a tube with two sides thicker and?
No.
My other question is actually Anuj from BFI. He asked me one question. He said, we talk about rusting in steel. हम जो bolt लगाते हैं हम उसको भी क्या we protect that bolt also with something so that when it goes in it doesn't rust over a period of time.
So normally bolts are hot-dip galvanized, so they have very long life.
Bolts are galvanized.
Galvanized, yes.
Normally your box sections, the tubular pipes are galvanized, as you said that during the making of the pipe itself, you have made it galvanized. It is rust proof from inside, from outside, everywhere. Bolts are also galvanized. When you are, the inside, the screwing it, that section, that joint, can you make it rust proof or is there any way? I don't know.
So we have seen some contractors doing spray paint, galvanized spray over the joint just before the erection.
I would like to ask Mr. Pankaj the reason why he used tubular section for beams in all these projects, because certainly that cannot be more economical, and plus you will have huge problems in connections in comparison to I-beam connection to a tubular column. So in both these situations, I don't know why tubular beams were being used.
So one of the reasons supply faster. Secondly, we felt that they were ready to supply cut to size rather than compared to the I sections, which are still fabrication is much tougher. So comparatively, we thought that looking at building faster, keeping one system is much better than going for a hybrid of concrete filled tubes and beams. And in a recent study we did work for one project, recently we have found that overall tubes, it is a airport project in Itanagar. For few of the buildings we found that from 141 tons by use of tubes we were able to bring it down to 82 tons. So I do think that in certain conditions there are good opportunities for reduction in steel consumptions, as has been projected also by use of tubes.
Yeah, as long as the member is primary axial force then obviously tube is a better solution. But for a bending member, a tube can never be an optimal solution, you know. So, I mean, airports have trusses. So, trusses are basically compression members. So, there obviously tubes are always cheaper. But for beams,
Sure, Pankaj permits, with your due permission, Pankaj. See, I mean, the idea of steel construction is standardization, right? If we use 10 sizes for a small structure, 5 tubes and 5 built-up sections, then you won't be able to achieve speed and efficiency, right? That is one. Second, any built-up section manufacturer, we may have some fabricators here as well, the maximum capacity they can do on a built-up section is 50 tons a day. Whereas the hollow steel section, which is being manufactured on a automated mill from Italy, Japan, Korea, we do manufacture 6,000 tons of tubes every day. So for a project like Delhi hospitals, where 15,000 tons of tubes is required, it's like 2 days off for us. But for a steel fabricator, it will take him like ages to fabricate that kind of built-up section and supply on site, right? So with, like I said,
yeah, effectively, but you are increasing the cost drastically. That's what the main point is.
No, sir, it's not because maybe 2-3% extra steel. Maybe
not 2-3%.
Maybe 5%, but then the speed.
Because the main disadvantage of an high section is the lateral bit, very less lateral capacity, which gets nullified by the diaphragm of the slab. So that goes away.
No, sir, but again, see, I mean, idea is speed, right? Like Dr. Abe said, that cost. Mr. Lal also said that 250 rupees per square foot is like just one cost, right? But when you look at the speed at which the building is finished, just imagine a hospital being completed before COVID, after COVID. See the difference, I mean, it can be for the whole community, right? A hotel building getting finished like 12 months in advance. I mean, the IRRs of that project can boost up by 300x, right? A school in farthest of the country area, if it gets constructed in 3 months, 6 months time, right? So I think, let's not get bogged down by like what is better. Idea is like to make a steel structure more optimal. I mean, 100% tubular may not be.
Anubhav, just a moment. What Pankaj is saying is very correct. We have to agree to that. What you are saying is the whole life cycle cost, okay? And the other benefit, you need something in a particular time. So this is the feasible option. See, if you can't produce that much of material of a form, and the other material which is available, you have to use it. It may be a bit costly. What you are saying is very correct. So we have to accept that. Your point is different because you can produce a particular thing more, so it is good for this project. That's possible. But given a choice and time, maybe a hybrid option. And I would also like to address Mr. Tempkia's concern. Yes, you are very correct. All bolts are not galvanized. On 50% or more than that, high tensile bolts are used. Even HSFG is not used. So those high tensile bolts, they rust. And when we accept the concrete with 10 defects, we will accept the steel with 1 defect also. And we will maintain that. We will maintain that. See, the entire section gets rusted. So we do the painting. That regular maintenance manual has to be given to the client. कि भाई इसको संभाल के रखना पड़ेगा. ज़्यादा concrete से तो थोड़ा सा कम ही पड़ेगा. But that is other thing. So your concern is very correct.
Ladies and gentlemen, before we wrap, we have certain esteemed dignitaries who have joined us today, our guest of honors. Well, yes, it is very important for us at APL Apollo to thank them. So with your round of applause, may I please invite Mr. Keshav Chandra, former Railway Board member and Chairman Rides. Thank you so much, sir, for taking out your precious time from your busy schedule and for being a part of this evening. With this, I would even like to extend this heartiest thanks to Mr. D.S. Gadia, ED, Airport Authority of India. Can we all please put our hands together for Mr. Gadia? Our sincere gratitude to you, sir. Thank you so much for joining us. May I please invite Mr. Chugh, ED, Airport Authority of India. Can we all please put our hands together one more time and join me in welcoming Mr. Chugh, the Apollo team. Thank you, Mr. Chugh, for joining us, for gracing this evening with your presence. Thank you so much. And with this, we'll even thank all our speakers, all our patrons of this industry who have joined. Dr. Anubhav Gupta. One more time for Mr. Anil Bansal. And the last one for Mr. Narendra Singh. Let's bring the revolution together in the construction industry, build better and build faster. Thank you so much everyone for joining us here. Do join us for the drinks and dinner. This is MC Priyanka Bhalla taking a sign off. Thank you.